Good morning, friends. Welcome to Water Resources Engineering class. Today's lecture again focuses only on the continuation part of yesterday's thing. Now here see one more problem, because all this is only how you work. The more you work, the more you get. So next is a rainfall of magnitude 3.8 centimeters and 2.8 centimeters occurring on two consecutive 4-hour duration on a catchment area of 27 kilometers, producing the following hydrograph at the outlet of the catchment. Estimate the rainfall excess and phi index. The moment rainfall excess or direct runoff or effective rainfall, all are same, and phi index. So now you see the data. What the data is, time interval is given, then flow is given. So what is the thing that which I need to do? You don't need to plot in the exam, but you should understand the process actually. So what I should do, you should always think actually, right? You should plot this, right? Once you plot this, what is your next step? Separate the base flow. How to separate the base flow? Starting point is this point, you know. The end point, how you will know? This is n days from the peak. N days from the peak. How to get n is equal to 0.83 into a to the power of 0.2. Do it and put it. So then if you draw this line, whatever below is base flow, whatever above is the direct runoff. That is what is the thing. So I have taken up directly here. So plot the storm hydrograph. Take a graph sheet, plot it. No way. Then separate the base flow by straight line method, right? 0.83 into a to the power of 0.2. So 0.83 into 27 to the power of 0.2. 1.6 days, 38 hours. From the peak actually, from the peak, this much must be 38.5 hours. So this should be that. From the data, direct runoff starts at t is equal to 0 hours, has the peak at 12 hours and ends at 48 hours actually. As n is equal to 36 hours appears to be more. So because when it is ending here, unnecessarily you don't need to take up to here, because here itself is the end point actually. Because after this, naturally it is receding only more. So that's why it is almost 5. It is staying as constant. So that you can take it. So that's what I have mentioned. Even if you take 38.5 hours, absolutely nothing. So then after drawing a straight line, then base flow is recorded as 5 meter cube per second. Now that I found that after joining this portion is at any point, if I check it, it is 5 meter cube per second. So what should I do next actually? So you see, so this is the observed flow given data. This is the base flow which we got it. So the base flow is constant throughout. It is 5 meter cube per second. This is what right now we have found, right? And time interval is given. So now if I put observed flow minus base flow is equal to direct. So direct runoff ordinates is equal to storm hydrograph ordinates minus base flow. That is what I have found here. So this is the way in the exam you need to do it. First you need to find out, right? If it is given in the exam straight away, then you don't need to take a graph sheet and draw. Otherwise, you have to draw it and you should separate it and put it actually. Kindly note that. So this is the thing. Then what is the depth of direct runoff? Directly equation. Sum of the 1, 2, 3, 4, 5, 6, 7. Sum of that. That's what I have done. Right? 69 meter cube per second. What is the time interval? 6, 6, 6, 6, you take it. So 6 hours. What is the area he has given? So depth of direct runoff is equal to, put in this formula, 0.36 into 70 into T is 6 divided by 27. If you put it, how much you are going to get? 5.52 centimeters. This is the answer. Now, what is the total rainfall? Total rainfall, he has given it as 3.8 plus 2.8. That means 6.6 centimeters. 6.6 centimeters is the rainfall. And this is the direct runoff. So, rainfall minus direct runoff is equal to, that is nothing but the infiltration. So, infiltration is equal to rainfall minus direct runoff. So 6.6 minus 5.52, and this is in how many hours actually? 8 hours. So infiltration rate is always phi index is nothing but rate of infiltration. So rate of infiltration means per hour how much? By divided by 8. That is what we have done. So this is the infiltration rate, and that is what we call it as phi index. So this is what you should understand. Following are the ordinates of a storm hydrograph of a river draining a catchment area of 423 square kilometers due to a 6-hour isolated storm. Derive the ordinates of 6-hour direct runoff ordinates and depth of direct runoff in centimeters. Assume constant base flow. So now here you don't need to calculate. Base flow is 10 meter cube per second and rainfall excess is for 6 hours. Right? Now you see time from the start discharge he has given. So from almost minus 6 to how much? 102 hours. So how much of time he has given? What are the ordinates? So what I have done? I have plotted the same thing. So time from the start discharge, and he has given base flow. So base flow. So what is direct runoff ordinate is equal to storm hydrograph ordinate. Suppose for example if I take this is 1, this is 2, this is 3. So then this is equal to 2 minus 3. That is what I have done. Same thing I have done here also. If you take it, this is 1, this is 2, this is 3. 4 is equal to, naturally 4 is equal to what actually? 2 minus 3. 4 is equal to 2 minus 3. So this is the ordinates. Any difficulty in this? Kindly solve yourself. So time has been given, discharge is given, base flow he has given. So naturally your problem is 50% solved. So then directly find out what is the direct runoff ordinates. So direct runoff ordinates. Then what is depth of direct runoff? Depth of direct runoff is equal to 0.36 into sigma O into T by A. So now sum is already sigma O, right? Then what is T is equal to 6 hours. Fine. A is equal to 423. Put it. This is the answer. Any difficulty in this? If at all difficulty is there, what? Base flow determination. Base flow determination also simplified. He has given it. So now what is the, finally you tell me what is the depth of direct runoff? 3.163. So the direct runoff depth is equal to 3.161 centimeters. Very, very important. This point you remember because this will be the starting point for the next lecture. Right? The entire direct runoff, whatever ordinates you got, corresponds to how much of the runoff? It is 3.161 centimeters of runoff. That means the entire ordinate of direct runoff results in 3.161 centimeters of runoff. Then again another problem I have taken. A 3-hour storm produced a flood hydrograph as given below. Assume a constant base flow of 4 meter cube per second. Determine the ordinates of direct runoff and also depth of direct runoff. The catchment area is how much he has given? 50 kilometers square. So now the data is given to you straight. So starting from time interval 0. So what is the interval? 3 hours. Delta T is equal to how much? 3 hours. Time interval. Then what is as given? Base flow is also given. Very lucky. Base flow is given. So naturally what is the direct runoff ordinate? That is nothing but actually storm hydrograph ordinate minus base flow is this ordinates. So can you find out this or not? So what is the first step? Gentlemen, tell me once again. Storm hydrograph ordinates are given. Time interval is given. So you need to do what? Separate the base flow. Then after separating the base flow, deduct the base flow from the storm hydrograph ordinate. If you deduct it, what you will get? Direct runoff ordinates. So if base flow is already given to it, there is no question of you don't do anything regarding separation. Straight away you put in the table and get the direct runoff ordinates. Then sigma O, as usual, T is 3 hours, area is given 0.36 into sigma O into T by A, it is directly in centimeters. So what do you mean by that? The answer, what the answer reflects, you tell me in one sentence. All the direct runoff ordinates put together results in a depth of 2.1384 centimeters of runoff. All results, the entire storm results, the storm hydrograph, whatever you have given, results in 2.1384 centimeters of depth of direct runoff. This is the wording that you should understand. Then small problem for you, it is actually a gate problem, like if the direct runoff hydrograph of a storm obtained from a catchment is triangular in shape and has a base period of 50 hours, the peak flow rate is 30 meter cube per second and the catchment area is 86.4 kilometer square. The rainfall excess that has resulted in the above hydrograph is, it's a bit question actually. Rainfall excess, effective rainfall or depth of direct runoff, all are same. So now you see, this is the triangle, right? The base is how much? 80 hours. Peak is how much? 30 meter cube per second. So depth of direct runoff formula I cannot use it, because if I have ordinates sigma O into T by A, I can do it. But there is nothing like this here. So that's why I go to the basics. From where 0.36 into sigma O into T by A, from where I got, I will go to that basically and then do the things. Area of catchment is given. So this volume I have to calculate. This volume is nothing but the area of direct runoff. The area of direct runoff is nothing but the volume of the runoff. So this area means area of this triangle. Area of this triangle, how you get it? You tell me. Half into triangle now. So 80 base into H is how much? 30. But units, this is hours, this is meter cube per second. So this hours to seconds we have converted into that. So all this will give you what? Meter cube. Area of direct runoff. Even previously also I told the same thing. Why I used trapezoidal formula? Trapezoidal formula only says that only the area under that to calculate actually. Divided by the catchment area. Catchment area is in what actually? Kilometer square. So convert into meter square. So we got 0.05 meters. So what is centimeters? 5 centimeters. So it is one minute bit question in the GATE exam. Straight away, the moment you have seen such type of things, the area of the direct runoff is equal to, it is nothing but the volume divided by the catchment area. But units you should be very careful. So this completes to be some of the first topic of the hydrographs. That means how really in problems we do base flow separation and how we calculate what are the direct runoff ordinates, and similarly how we can calculate the depth of direct runoff. These are the things we worked out in this particular lecture. Thank you.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.